Hey there, it's Cooper Codes. In this tutorial, we're going to set up our Apollo server in GraphQL locally, connect that server to MongoDB Atlas, and then create a message object which we will use to send and store data on the MongoDB Atlas database. All right, let's get into it. First things first, you're going to want to make sure you have a text editor and then a terminal in whatever directory you're making the project in. An important part of JavaScript projects is the package.json. So we want to initialize that here by doing npm init --yes. And this is pretty much going to give us a pretty generic package.json file. And this is important because now we have the ability to add on more packages on top of this. A couple of ones we're going to want for this project is we're going to say npm install, which is saying for this JavaScript project, install these dependencies. We need Apollo-server, GraphQL, Mongoose, and then NodeMon. These are all the ones we're going to need for the full setup of the JavaScript stuff locally. Now that we have all the necessary technologies installed locally, we can go to our browser here, go to MongoDB Atlas, and get started. If you create an account, this will probably be one of the first pages you get greeted with, and just click the Build a Database button. It might be a Create button right here. It's going to bring you to the same page. And you want to make sure you do the shared server because then you're going to be able to have it be 100% free forever. That's something great about MongoDB Atlas for using it initially. And choose whatever is closest to you. Make sure it's this MO sandbox so you never get charged. Additional settings you don't really have to mess with. Cluster name, we can name this whatever we want. I'll name it Apollo server setup, and we should be good to go. Create the cluster, and I believe it should take a couple minutes to actually get started. So go back to your databases, and eventually you'll have a fully set up database. It will take up 3 to 5 minutes, so give it some time. But now that we're here, we can press connect, and then go to connect your application, and then you're going to see this. We're going to use Node.js, so this is good, but this URI string right here is kind of what we care about the most. So we're going to copy this string here, go into our code base again, and make an index.js file. This is going to hold our Apollo server. This is going to hold kind of some Mongoose stuff we have to do. So this is an important file. And one of the main things it's going to have in there is this connection string. So let's just name it const mongodb is equal to this string. And you'll see there's a couple things here. One of the main things is this, is we have this admin password. You want to make sure to go in your database access over in MongoDB Atlas. This is a huge mistake a lot of people make, is they don't understand how the admin stuff works. Right? It's giving you admin by default because it makes admin for you. But you want to make sure you go in here, edit, and then type in a password you're going to remember. For example, I'm using the password Cooper Codes. I'm going to use the password Cooper Codes, and then this is what I'm going to be using, and make sure to press update user, right? And so now when I'm the admin user, my password is going to be Cooper Codes. So I can just go in here and then type that in. And it already has my username, my password, Apollo server setup. That's already the cluster we're on. We don't have to change that. And then the my first database. A huge mistake I see people making is they try and change this my first database. Don't do that. Just keep it as my first database. You'll see when you connect what this does. It pretty much makes all your, like uploads, for example, when you like push an object to the database, it makes it under a my first database part of it, if that makes sense. So don't mess with this. This name doesn't really matter. It's going to make that database for you when it actually pushes to it. So hopefully that clears things up with this string. And now this is a string we can actually use to fully connect. Now we can finally get into the actual setup of the Apollo server. So we can do this, const Apollo server, make sure it's in brackets, is equal to require Apollo server. So this is getting the Apollo server from the actual package Apollo server in the Node package manager, right, in our Node modules. Next thing we can do is pretty much make the server and initialize it. So we can say const server is equal to new Apollo server, and it's going to take two things. It's going to take something called type defs, and it's going to take something called resolvers, which we are going to get into in a second. These are actually variables we need to define. So let's do that right now. For this type of project, we need a overall folder structure that's going to make sense. One thing that we need is a models folder. This is going to hold all of our Mongoose models that our Apollo server is going to eventually use. Then we're also going to want a GraphQL folder. This is going to hold all of our GraphQL code like mutations, queries, things like that, right? Remember guys, this isn't a GraphQL tutorial. This is more of a setup tutorial. So if any of this is confusing, I'm planning on making more tutorials like this in the future, just so you guys know that. But we can go into GraphQL, and a common thing we would do here is go in, and we are going to have our typedefs.js. And then we're also going to have a folder inside of here for all of our different resolvers that we would expect to have in our application. And this makes it easy for us to grab these from index.js. So in index.js, we can go in and say const typedefs is equal to require. And remember, we're not looking at npm anymore. So we're going into our own folders, GraphQL/typedefs. And we have to make sure we make these correctly so the require statements work. And when I say make these correctly, I'm talking, when you say require GraphQL typedefs, you have to make sure that this is a module and that it's exporting something. And so we have to structure it a very certain way, just so you guys know what's going on. And then we're going to have the const resolvers is equal to require./GraphQL, and then it's going to be that resolvers folder. And you'll see this is an entire folder, so we want to make sure we also require this the correct way. Okay, and so now we have a server setup. Typedefs is going to be undefined. Resolvers is also going to be undefined right now, but we're just getting the initial setup there. And so don't worry, this isn't going to run yet, but we're getting there. The next most important thing we're going to have to do is now go in and get Mongoose ready. So Mongoose is going to help our Apollo server actually talk to MongoDB Atlas. That's why Mongoose is involved. So we can go in here and say const mongoose is equal to require Mongoose. And Mongoose is a super common way in JavaScript to connect kind of like a middleware to your database. So Mongoose is used all the time. And if you just look up like Mongoose connect to database, you'll have a bunch of resources that are probably more in depth than what I'm doing here. So now we can go to the bottom here. And like I said before, mongoose.connect is super well documented. You'll see it's expecting a URI string, kind of like we have up here. And so we can use our exact same string, MongoDB. It's also going to expect some options. One option that we can use here is use new URL parser, true. This is just part of the documentation. This isn't like I knew some JavaScript thing to know why this object works. It's all in the Mongoose documentation. So just so you guys know where that's coming from. Then we can do a .then, and this is pretty much going to wait for the event of when our MongoDB connects. And so we can say, okay, when this happens, we want to say MongoDB connected because it didn't fail and it connected to this MongoDB string is what Mongoose is doing for us. And then we want our Apollo server to start listening if this connection actually went through. And one way we can do that is we can say return server.listen. And then we want to make sure it's on a certain port. So we can say port 5000, I think makes sense. It doesn't really matter what this is, but just say 5000 to be consistent with what I'm doing here, I'd say. And then we can do another then here where it takes the result, it takes the response here. And then it says, because it's waiting for a response from our server to actually start. And so now when that happens, we can say, okay, we know that our server is running. And so we can say this. And you can use backticks here to have a variable in your string. So you can say server running at result.url. And that's also part of docs, like the formatting of what the result looks like. If you don't know how to do this string formatting for saying this and you're getting lost with the backticks, don't worry, I would just console.log server running would be an easy way to do this. And so now we have a basic idea of what our code should be looking like for the MongoDB server. One thing we want to do is take this const MongoDB and then bring it down to, let's say, like right here. You usually want all of your require statements at the top of your folder. That isn't like a rule, but it's an easy way to make your code more readable. So now we have our index.js set up. We can get into actually creating the GraphQL things we need for our basic server to start running. All right, so now we can start to create some basic types and inputs, pretty much GraphQL stuff to create a basic application. One of the most important things here is you can do const, make sure to use brackets, GQL is equal to require Apollo server. What you're doing here is you're getting this GQL keyword outside of Apollo server, and it pretty much allows you to write GraphQL code inside of JavaScript. So you can do module.exports is equal to GQL and then make sure backticks. And now everything inside here is pretty much stuff that's going to be GraphQL like syntax. So you can say something like this type message because we want to send a basic message to the server. We can say text is a string. We can even do more interesting things like created at string, created by string. And this is pretty much basic GraphQL stuff. Now we want to do our queries or our mutations for the string. So let's say this, or for the message. Let's do a type query. And then this would just be a very basic one you've probably seen in GraphQL, which is getting a message by its ID, which is something automatically created by Mongo. And then also a mutation, which you might expect is going to be that create message. And so this is going to make a message in our MongoDB database. Also, just to have, different examples of using GraphQL things for your projects, you can also do an input type here, which is going to be message input, which is going to expect a text, and then it's going to expect a username. And don't worry, we're not doing it like users. This is just something we can pass in for fun. We're not doing authentication or anything crazy. And so then we can take that message input and make a variable. Message input here is equal to that. Make sure capital M on this one on the right, message input, because now it's going to be referencing this message input right here. And yep, then that's going to return a message. Okay, so now we have some basic types to work with in our GraphQL application. All right, so now we can kind of start to see where Mongoose is going to come in and the models are going to start playing in here. So we have this type message, but we don't have a model actually attached to it. So we want to go into here and we want to create a message.js model. This is going to be some pretty generic stuff that you can look into the Mongoose documentation for, but it's going to be const model and schema is equal to require Mongoose. And so now we can make a schema for what we expect our message to look like. So we can say const message schema is equal to a new schema, which is a Mongoose type as you see above. And it takes in a bunch of different parameters for what you want the schema to be. So text is going to be a string, created at is going to be a string, and created by is going to be a string. Remember, why am I making all of these different things for the schema is because if you go to type defs, you can look here and say, okay, these are all the different things we need in our model. And so then in our model, we make sure we get all those variables. Super important here is you're going to do module.exports is equal to model. And this is where Mongoose comes in again. And you say message, so that's the name of the actual model itself, and then the schema of the model, so it's going to be message schema. All right, so now we have an actual model to use when messing with the resolvers over in GraphQL. Okay, so now we can finally get started on creating the actual resolvers for messages. You'll see in our type definitions here, we define message and create message, but we need to make these things like actual pieces of code that work, like the actual create message code. And so we want to go into resolvers, and we can make a messages.js. And this is going to help us create the actual code for the message function, and then the create or the message query, and then the create message mutation, right? So let's go in here and get started. One of the first things we're going to need is the actual message object from our models. So we can go in here and say .. It means we're going back 2 folders. Then we're going to go to models, and then we're going to go to message. So this is going to get us that, right here, I'll show you guys. It's going to get us this model with the message, and it has the message schema. How this code gets formatted is it gets formatted in a way that makes it easy for kind of scalability and like reliability, if that makes sense. So we're going to have all of our mutations in one spot, and then all of our queries in another spot. So let's work on the query first because it's actually super simple. Is we have this query here and it was defined as message. And when I say defined, I'm talking about right here. And so we can go to message. We don't need this first parameter, but we do need the actual ID that's being passed in. And so then you can use a little arrow function just to do this in one line, is you can do message and then find by ID and ID. And this is some Mongoose related stuff. Okay, so now that we have the message code all done with the query, we can get into an example mutation. So I'm going to use asynchronous functions here just to do the mutations. This is kind of how I usually code my Apollo server stuff. And it makes it pretty simple, it makes it pretty easy to understand. One of the easiest things here is we actually have a message input defined right here. And so this is going to come in as an actual JavaScript object. You can imagine it's literally like text is hello, and then username is, Cooper codes. this is kind of what this object is coming in as. And so since we know that this is the object structure, we can go over, we can even take this, go over here, and we know it's going to look like this. And so we can destructure this message input where we're going to say message input, and this is JavaScript object destructuring if you want to look into this further. And then we can say is an object and it has two things, the text and then the username coming in, as we can see right here. Since this is a very basic kind of push data to a database thing, we can start by just filling up a message. And when I say a message, it's our schema here in Mongoose. We can fill this up with all of our necessary data here. So it takes in an object and then it wants all the different attributes here. The text is going to be equal to the text passed in right here. The created by is going to be a username. And created at is also an interesting one. We can just use the date object in JavaScript, and then we can do like to ISO string, I think is one. Don't worry about this. This is just an easy way to get a created at thing so you can see that your messages are being sent at a certain time in your database. Okay, and so this is our full object being filled with information. So now we actually have this model object with all the information necessary. And so now we are going to set up our response here where we say await, and this is where this async await comes in. Await new message dot save. And it's important to recognize that we are in a server, and in our index.js, we have this MongoDB here. So it's being saved to whatever this server is kind of pointing to, if that makes sense. And that's kind of how we can work through our code, is make a save here, and then we can even console.log this response to make sure that it's actually working. And then we can return an object for our GraphQL, which is going to show id results.id. And then ... just means the rest of the attributes in result is what this means. You'll see ... res._doc is kind of strange, but it's just a quick way to kind of show the rest of the attributes that's necessary for this return statement here. And remember, not a GraphQL tutorial, just showing you the basic setup. One quick note is that over in our index.js, we have our resolvers defined as require GraphQL resolvers like this. When we use this, it's expecting an index.js file to exist to give us all the different module exports it needs. And so we can go into resolvers and create that index.js file. And I'll show you guys in a second what I'm talking about here. So what it's expecting is this. Get your, messages resolvers as a require statement from /messages. And as you can see, messages here has a module that exports. And so it's getting this entire object is what that require statement's doing there. And so the same way, we have to have a module.exports for this folder. And it's going to pretty much be query and then mutation, because those are the only ones we're currently using. And inside of here, we're going to say, okay, in messages resolvers.query, we can see here, this is messages resolvers is this object, and then .query is this. And so .query is the information right here, which is all the different queries it needs. And so this index.js is helping us consolidate all the different, if we had a bunch of different resolvers, for example, like messages, users, other things, we can consolidate them all to one place and make it easy to understand. And in here, we can do the exact same thing with the mutations. Messages resolvers.mutation. And it doesn't look like this makes a lot of sense when you only have one resolver. But once you have all your messages, once you have all your users, a bunch of different stuff, it makes your code base significantly easier to understand. All right, so now we are at a point in our application where we have everything set up. We have our type def set up, we have our resolver set up, we have our Mongoose connection set up, we have the Apollo server itself set up, everything set up. So we can go in here and then say nodemon, or node, doesn't really matter. Nodemon just makes it easier to work with changes. Say nodemon and then index, which is pretty much pointing to this index.js file. And as you'll see, MongoDB connected, which is super great. If your MongoDB didn't connect, make sure to go over what I discussed in this MongoDB URI thing, and also make sure that you have your admin password set to the right thing. All that stuff's super important, and it can be frustrating, but make sure you triple check everything. And we can go to our browser here and see if we go to where we have the port, which is 5000, we can go to localhost 5000 and we can query our own server. All right, so now we can get started on creating an actual mutation for our MongoDB server. For the sake of time, I'm just going to copy paste in what the mutation looks like for create message. I can explain this really quick though. So create message takes a message input block this block is going to be expecting two things. The text, I can say hello world, and the username, subscribe to Cooper Codes, pretty funny. And then you can see all of the returned things in your actual GraphQL here. So you have text, created at, created by, all these different things can get returned. And so now we can run this code against our server, and it's going to show us that created message. An important thing here is this created message pretty much tells us that our resolver code, and when I say resolver code, I'm talking about the code right here, it didn't run into any errors, which is good because that means we should have an object saved on our actual MongoDB Atlas database. So let's go in here. Oh, it looks like something may have happened. And so now we can press Browse Collections, and then we can go to My First Database, and you'll see you'll have an actual block of data which goes under Messages here. And I said this a while ago in the video, but this is kind of why the name of the database doesn't matter, is because you'll see it's going to instantly create that database for you. So MongoDB is kind of confusing, especially Atlas is confusing on what this actually means. But now we can pretty much go in and say anything else. So this is another message. We can run this query again and no errors again, which is great. Make sure to actually refresh this page. It's kind of sketchy on if it actually updates live or not. Sometimes it does, sometimes it usually doesn't. And you'll see we should be expecting two messages here. And as you'll see here, there's an ID associated with these messages. It's created by Mongoose, so every single thing has its own unique ID. And you'll also see our created at is, showing that correct date.now, at least for my local computer. Yeah, this is pretty much the full stack setup. So from this point onwards, if you're working in your own GraphQL project, you pretty much have all these structures set up to where you can add more queries, more mutations. You can go in here, add different models. You can do like a user model and then have authentication that takes place in the, create user part of your application, all sorts of different things. And so this is just the basic setup to get your code base started. I do plan on putting this code base on GitHub, so look in the description for that. And yeah, thanks for watching.